So this is some pictures from my farm. So I'm Trevor Hardy from Brookdale. We're one of the largest diversified fruit and vegetable farms in New England. Even though we're in New Hampshire, we're right on the border of New Hampshire and Massachusetts, right next to the city of Nashua. So we're about 40 minutes outside of Boston without traffic on the New Hampshire-Mass line. That kind of references you where we're at. So we're currently operated by the 5th, 6th, and I'm the 7th generation. We farm around 600-700 acres. We also grow around 10 acres that's certified organic. And we have a huge wholesale operation out our way, which is all direct market to consumers through grocery stores and other farm stands. We do a lot of retail, pick your own. And then I run our irrigation and row crop supply division. This is just an image of our farm in the central location of it. We own a lot of land right in the center of Hollis, which is a rather known town in New Hampshire, and it's quite picturesque. And those are some pictures from way in the past on the side there. But the Brookdale Farm Supplies Division, we're the largest agricultural commodities supplier in New England, and we cover a lot of New York as well as far as row crop supplies. So plastic, drip tape, row cover, all the things you need in your consumables to get going. And I'm kind of the last one left in the region, and we work with all the different suppliers. So other than being one of the largest farms around, we also help manage all the large farms and small farms. We work with anybody from a half acre or backyard garden all the way up to a couple thousand acres. And we work with all them and all the different industries partners such as Extension and NRCS and folks working on SARE grants and other things throughout the region. So a little bit about what I want to talk about today is some experiences that we've seen with irrigation in our region and the climate change we've been experiencing with it, and really the lack of knowledge where people think they have irrigation and it's working. And there's a lot of misunderstanding about irrigation that you had 30 or 40 years ago. The technology has developed a lot more to utilize water a lot more efficiently, so you can weather those extreme climate changes a lot better with limited sources of water. So we're going to look at a bit of uniformity issues there. We're going to talk about some new technology that's out there. There's still a practical application, at least in our region. You're going to hear me talk a lot about the Northeast for overhead irrigation because it's also cold where we are. We have a lot of frost protection that happens out our way to sustain a lot of our crops. Then some electronic soil moisture management that we're doing in the region. And we're focusing a lot on soil health and cover crops and how that plays into roles on my farm and expanding that with irrigation uses at other folks' farms. And then some regional tips that we've got and that I like anyway. So a little bit about irrigation is I find that people that get into drip irrigation, a much more conservative method of irrigation compared to overhead, a lot of people try one or two things at the beginning and then they never really look at a whole system plan. They get going and they keep building these systems or small little components of their irrigation system, and then before they know it, they're trying to irrigate 20 acres off of a 2-inch supply line, and the math just doesn't work out. So typically we work with a lot of growers who end up with NRCS grants for irrigation cost share for improvements, or they're smart enough to say, hey, we want to grow our farm, let's sit down and work on a future system design. So we set the framework for their irrigation system to work from the beginning where they want their farm to be in 10 years instead of just starting and trying a few things. So where we do a lot of work right now with folks is updating and improving their system design so that we have the right pipe sizes, the right pumps, the right filters so that they can actually move the water around their property to be able to have the right pressures to operate the irrigation that they need. That's where my engineering background comes to play. But where a lot of this irrigation system design is critical is the most hard to understand concept that people are starting to adapt towards is irrigation uniformity. Understanding how uniform the distribution of that water is out in their field. So this is a great visual where when we're talking about irrigation uniformity, we want to know what depth we're controlling the water to the root zone of that plant, how long that row is, and what types of conditions are we dealing with, soil type, elevation changes, evapotranspiration rates, what's going on in that field to get proper uniformity. And this lovely picture here shows at the top we've got great uniformity. We got a nice flat row of corn there, and the water is distributed evenly throughout the entire length of the row. This middle image is a representative sample of, say, somebody chose the wrong flow rate and drip tape, where possibly at the end of the row they were running out of pressure and flow, and the back half of that individual row wasn't getting 20 to 30% less water compared to the rest of the field. And then the bottom image is what I live. So farming in New England, there's nothing that's flat. Most fields have 20 to 30 feet of elevation difference across all of it. There's a very few lucky farmers that are on some riverbeds that have some stuff, but that's not even 10% of the region within our location. So we're all dealing with hills or challenging terrain. So elevation or contour farming or dealing with that really makes it challenging to get effective irrigation done out in the field. So this whole middle hilly section or wavy fields and that kind of thing is something that we have to deal with all the time to get good uniform distribution of our water. So it creates a lot of challenges for us. So in this picture where we're trying to look at uniformity, which crop do you think is going to grow better? The ones with these tiny little circles or this nice uniform distribution in the bed, right? This side's good. That's a great image of good uniform distribution of water, where here they possibly chose the wrong drip tape and the wrong spacing. It's flowing too much water and leaching out down to the field because it's saturated. It's dropping too fast rather than letting it expand out to the entire soil profile at a slower rate to saturate the entire area. And I like to use that visual because when we're talking about an acre inch of rain at 27,154 gallons, that low flow drip tape, where we deal with a lot of small farmers who in our region are trying to irrigate their fields off their house well, because there's not a lot of municipal water around our places. Most of the house wells in New England make about 5 or 7 gallons a minute of water, so very little water, okay? If for them to get an acre inch of water out in their field, for 24 hours just to do an acre, you need almost 20 gallons a minute of water. So it's not really feasible for us to do a lot of irrigation in New England off of wells. It's a very, very hard thing for us to do out there. We just don't have the aquifers beneath our soil. So most of us in New England are using surface bodies of water, ponds, rivers, brooks, streams, or there are the fortunate few that do have a good well. But that's where most of us in the Northeast are irrigating from. So the biggest change in irrigation, about 25 years ago when drip irrigation really started hitting the market, there was a lot of different manufacturers and suppliers. And unfortunately, this is where my farmer hat comes on, is a lot of things when you look at the investment of irrigation costs, it comes to how much you have to pay to get that product. And a lot of people are saying, well, this product costs me $120 for a roll of drip tape and this one's $140. Well, it's the springtime when I'm buying all your supplies, and a lot of that's financial planning, and more often than not, a lot of farmers opt out for the cheaper products. And it doesn't necessarily mean that it's giving you the best performance. That's where a lot of more advanced growers or people focusing on their irrigation uniformity and putting together a good crop at the end of the year, they're future planning to make sure they get good products or pressure compensating emitters in their drip tape, so you end up with a situation where you have uniform distribution of water using a pressure compensating dripper on a slope, where that cheaper drip product that's not pressure compensating on a slope, most of the water is falling out at the bottom of your hill and you're getting about 20% out at the top. So what's that mean if you're a farmer? You're irrigating to a point of soil saturation. You're going to look at that field and you're going to say, hey, that pepper plant on the top of the field looks dry. I'm going to water that till I feel that that pepper plant on the top of the field has adequate saturation. So what's happening to that pepper plant at the bottom? It's getting overwatered. So when you start looking at some of those costs, as it costs a lot of money to irrigate, you're typically spending 20 to 30% more in your irrigation operational costs for a non-pressure compensating emitter, because you're wasting more water because you're using that driest point, that high spot on the hill, to make your irrigation decisions. Where if you got a pressure compensating dripper, you can probably save about 20% of your water per application because it's getting distributed more uniformly in the field. That's some of the things that people are looking at now. And we're going to talk about that. So when we're looking at how water is held within the soil on those hills, I'd go back to this in New England and say, well, up here I got sand, and down here I got clay. And that run might be 400 feet, and I've got 5 different soil types in 400 feet of field. And that's what we live with. Nothing's standardized, everything's variable. So it's really, really hard, and that's where we look at picking the right tool to help us best uniform that out into the field to deal with all those different variations. So as water moves differently through all these different soil types with respect to drip, we got clay where it's really kind of shallow, we got loam where it's a bit more even, and this is our biggest problem, is the pockets of sand, where we hit that saturation point in the soil and the water just goes straight down. It doesn't move laterally. And where we have a lot of rolling hills, the sand's typically in the middle or at the top, and all the loam's washed out to the bottom because all these fields have been farmed for 200-300 years. So when you're looking at that, it's really how far does the water move from that dripper line. So part of that uniformity discussion is where are you placing those drip lines in your field. And there's charts and tables which you can look at if you're doing a single row crop, double or triple, which we don't need to get into, but that whole idea is the concept of where is it placing it and knowing what soil type you have to figure out how far laterally that water will move when you're choosing to irrigate. So with coarse sand, we're only getting on average about a foot of travel away from the drip tape, where with fine sand it can move a little bit farther, but when you look at that loam and clay, we've got great lateral movement. So that's where picking a drip tape to fit that uniform schedule with 3 different soil types on a hill really becomes challenging. So we can never hit 100% uniformity, but we can get awfully close. We're shooting for 90 to 95. That's a lot better with a pressure compensating drip tape than getting about the 70 that we're getting with conventional tape out there now. So another trick too to this is pulse irrigation versus continuous irrigation. And I'm even guilty of this one. You're going to see some slides here future on where we're just hearing from Amy in the West Coast where they had a severe drought in 2015. Well, we had one on the East Coast in 2016. And it was quite severe. On my own farm, we irrigated about 26 million gallons of water that season because we have to report everything. And we emptied every pond and every location. And that's where this became a little more apparent to us to stretch those crops on. We were irrigating for maybe an hour or 2 at a shot twice a day instead of our 4-hour continuous run, so we can stretch that source out instead of saturating the soil profile and letting the water go straight down out of the affected area of the root zone of the plant. So we're all about focusing in that zone where the plant's growing rather. And this is this lovely simulation. Sorry, I thought that was there. Now you can see it. I'm a little colorblind, so that's a hard one for me to see. Can't see the blue. But, you know, this is that question you ask yourself, does irrigation pay? Now, for us, a lot of folks are growing sweet corn out in that market. So if you have a row, if you're actually burying drip tape or using it while you're laying your sweet corn and something happens there, you're losing a whole row of corn, that's a cost to the farmer. That's where we want to make sure our systems are upright and they're running correctly, because if they're not, you can see where they're failing you. And that's just lost profit right there. So one of the things that affords at least me as an irrigation designer and some of the farmers to look at these things is, before we look at these new drip tapes, is we can use some water conservation tools in our design practice of working with a farmer or looking at a new grower or an existing grower who wants to improve their irrigation system as, hey, do we have the most efficient delivery system out there? And this is where a bit of the history or hierarchical things in family farms, which is what we deal with, is my father's always used 4-inch pipe, and then he went down to 2-inch, and that's how we distributed it out in the field. Well, when we put that in the simulation software, it says, okay, maybe that example is that one on the far side where they're looking at 3-inch lay flat with all those colors. That means, it's bad uniform distribution of water. And I say, well, if you spend a little bit more money and do it all in 6-inch, you've got better distribution of water instead of poor. And more often than not, those types of decisions, you need the data to be able to show the older generations the benefit. And without a visual like this, just talking to them, that's something that really opens their eyes and then they say, oh wow, now I can understand what I need to spend that money for. So one of the most revolutionary products in the drip world that we deal with a lot, now as an irrigation supplier, this is where I'm a little bit different than just being a farmer, is I deal with all the major manufacturers of drip tape. And I sell all the major manufacturers, but we have that choice as a farmer. I'm not dedicated to one, so I can choose from all the different types. And this is an example of one product that we like a lot in our New England market, and that's Toro's product called Flow Control Drip Tape. It's one of the only pressure moderating drip tapes out there in the market. That helps us here with this image. If you look at the bottom picture here, I can't tell if the pointer's working. This is an example of standard drip tape where we were talking earlier about that hill scenario where less water is coming out at the top of the hill and more is coming out at the bottom. Flow Control is a pressure moderating drip tape which makes each dripper drip consistently, so you're getting a more uniform delivery, which saves you water and time during your irrigation cycle. At our farm and throughout New England, I do irrigation field days every year in every state. And it's really eye-opening for a lot of small farms. New England's kind of the home for a lot of small, diversified growers. And this is just an image where we did a field trial, and we ran out some drip tape, and you can actually see where the regular flow control drip tape next to regular tape has more uniform distribution. Same spacing, but see how uniform the drippers are going down that row? The water's touching itself, where here it's not. You ran that in 5 minutes, you can actually see the benefits of flow control working. And that's something that's eye-opening for a lot of folks. So when you get to that, they say, well, how's it compared to the traditional drip tape? Most common used drip tape in our location is all 5/8, because none of us have rows longer than 800 feet or 1,000 feet out there. So the most common used is a 12-inch, what they call a high flow, or a 0.45 dripper. So on a traditional tape here, it says for 90% uniform distribution, I can only have a max row length of 524 feet. With Toro's product, using flow control, because it's dripping more uniform, it can also carry water more uniformly a longer distance. So with that same tape, I can now satisfy a row unit at 90% uniformity that's 633 feet long. So I'm gaining length while distributing more water. That's what makes this product unique. So primarily where this is getting used right now in the Northeast market, a lot of high value crops, peppers, tomatoes, are short crops like lettuce, greens, some cucurbits for some folks. They don't necessarily spend the expense per acre to go to the flow control tape, but definitely multiple season crops like strawberries, raspberries, those kind of things. That's where this is going. And it's only about $20 more a roll, or 20 bucks more an acre in terms of cost for this product. Same thing is experienced now in the evolution of orchard tubing or drip tubing for permanent systems. There's different types of drippers. So that's just an image of apples and hops that we're using that on, where we have pressure compensating drippers built into the tubing, which allows each dripper over that 30 or 40 foot of elevation in row to drip at the same rate. Now, this tubing is available in the market compared to a non-pressure compensating tubing, and that's about $30 to $40 more a coil per thousand. So sometimes when you talk to growers who want to irrigate 40 to 50, maybe even 100 acres of a new planting of apples in a year, that cost can be significant. So you have to explain that, hey, you're running your pumps less, you're using less water to maintain that crop. And the second added benefit for both conventional and organic growing in all these uniform discussions is that a uniform system allows you to fertigate and or chemigate a lot more effectively. So if you're feeding your crops as you're growing and giving them fertilizer, if you have better uniform distribution, your crops are going to grow more uniformly, then you have to have less fertilizer inputs to maintain them. That was a bit on orchard tubing, but here in the Northeast, where we have frost protection as an issue, primarily for strawberries, the old days of aluminum pipe and impact sprinklers is where a lot of people were living up in our region. And just recently, Netafim came out with a product called a MegaNet sprinkler, and this allows a small diversified farmer to use an overhead impact sprinkler that utilizes the same supply line and support structure that they use for their drip system. So the farmer only has to stock one kind of tubing. They don't need to buy expensive aluminum pipe, and they're getting distribution using these new sprinklers at 24 by 30 of greater than 85 to 90% uniform distribution, where the old impact sprinklers were getting them around 60%. So that means they can overhead irrigate, frost protect strawberries using less water with better uniform distribution, and their crops are going to survive better. Plus, it allows them to only stock one type of material that they can use for both overhead and drip. So it's a cost savings there. We even get to the point where a lot of our freshly tilled ground, where people are planting direct seeded carrots, onions, lettuce, and that kind of stuff, a lot of folks are pre-irrigating out there because a lot of our moisture isn't happening in the spring and the summer anymore. We're all getting it in the winter. So you're going to see some graphs about that in a minute. So that's another tool that they're using these sprinklers for, is to get good uniform distribution just to pre-wet a planting bed. This is another example too that I just love to throw in there. That's my lovely brother. So when we do these kinds of irrigation systems and stuff, and you got to make fun, the trick is don't bury your irrigation system and put it in the fall and then forget where the pipeline is that hasn't established in the soil structure while you're out there working, or you get lovely embarrassing pictures like that. So you got to break it up every now and then. But the biggest thing when we talk about these new tools is people are struggling in our region to figure out, how long do I need to run these tools? You spend all this time and money putting in a new irrigation system, but how do I tell when is enough enough? How's the soil wet? How's the soil dry? Anybody in here participated with NRCS and got a irrigation water management contract? A couple folks. In every one of those contracts, they'll take your individual soil type and give you an image of how to manually check for soil moisture in your type, by taking a clump of soil in your hand, forming a ball, and letting go of it, and seeing how it breaks out in how many chunks to be a representative sample of judging your soil moisture. That's a good touchy-feely way to see if it's working, but it's not really a data-driven approach. So that's where a lot of folks now are looking at soil moisture meters, and that's where I thought it was great that Amy was looking at that at different depths where they're doing their dry farming, because all of us that are irrigating we're using these soil moisture meters to measure the moisture that we're applying in irrigation within that root zone. So right here, we're going to have a shallow soil moisture meter and a deep soil moisture meter by crop, which the folks from Aerometer and Watermark, one of our two major soil moisture meter suppliers, they list your crops and the depths of the two different soil moisture meters that you need to measure where that is within your root zone. So what's nice about these is the aerometers have been around for all you folks that don't have freezing climates. Those work great because you can charge them with water, and it's a clay tip and it draws the moisture out to give you a reading of soil moisture. But for us in New England, where things freeze all the time, if we forget about that out in the field, we're down like $90 a sensor. So we use a lot of these Watermark soil moisture sensors because they can take the freezing and thawing. It doesn't damage the sensor, except we have to go around with this little digital thing and click on it to get a reading. I'm going to show you that here. And where we're measuring soil moisture, it's in centibars or kilopascals, and basically to dumb it down is 0's wet, 100's dry, and depending on your soil type, you're turning your irrigation system on between a decision of 10 and about 40. So when it creeps up, the higher it creeps up, the drier it is. So if my shallow soil moisture sensor is at 40, but my deep one's at 20, that means, okay, maybe I only need about 2 hours of irrigation. Where if they're both in the 30 to 40s, it's drying out pretty deep in the soil, we need to run the irrigation a little bit longer to return that saturation to the soil. And how we're measuring that data, other than going out there with a clipboard, is in the Northeast, we've got two systems that we use. We use the NIWA weather network, and another company called Rainwise that supports our systems out there, and they have a digital input. So for those of us that are fortunate to have internet connection or pay for a cell phone connection, we can get it online. So the NIWA application, they have a model that uses evapotranspiration and soil moisture that gives us a depletion table of how much water has gone out of the soil system and how much we have to replace in gallons over here. So it can take a future forecast, if this pointer works, of moisture, what's happened in the past for rain, what's predicted in the future, and gives you a deficit in negative number of gallons that you have to replace to the soil to get to saturation. The Rainwise software actually records it. So this is soil moisture data from my farm. in 2016 when we experienced the drought. And this is actually in a block of apple trees, not vegetables. So we started here in April and went to December for our window. And you can see here the red's the soil moisture, and this green box is our optimum range where we want it to be. In the beginning we had a couple showers and we were really wet. But then we're heavily irrigating right around here, and you can see right there anything above 45 or 50, you can say Trevor screwed up. So I forgot about irrigating that zone for about a 2-week window. But right here is our major inflection point where I ran out of water in that pond. I physically pumped it dry. That was 27 million gallons of water, and it was gone for the rest of the season. And the blue lines here are rainfall, and you can see that I've never seen a reading that dry anywhere in New England where we were approaching 100. I mean, that's basically no soil moisture left. And then we finally got a rain event, one of those thunder boomers that gave us 1.5 inches, and that drove that line back down. And that, for us as farmers, we can start looking at that soil moisture data, and we want to effectively control the bars within that box. Whenever we get outside of that box or below that line means we irrigated too long. Above that line means we lost control of our constant soil moisture. And that's what farmers are starting to use now as their decision points for irrigation. So this past season, we tried to do the same thing, where we looked at rainfall and temperature, and we actually had 2 mini droughts this past year. We had a real wet spring, but in the middle of the summer and then the end of the season, September, October, we still had 2 significant droughts with soil moisture. And just as a comparative thing, these are some graphs where I work a lot with extension in all the different states, but my closest partner, George Hamilton from UNH Cooperative Extension, we looked at rainfall in 4 different locations, and this is ours. The title didn't show up here for some reason, but in that target time frame where that red arrow is, we only got 3.5 inches of rain during the primary growing season, where other parts where we're looking at Massachusetts and Connecticut and neighboring states, they got 5.5 and 7 inches of rain. So it was really showing us that we were in a severe drought in trying to manage the regional weather within, say, 100 miles of our location. The irrigation had to be more focused on because the rainfall was so inconsistent just within 100 miles of one set point. Some people could have 4 or 5 more inches than you than the others, that it really made us have to focus on our microclimates to measure our point of irrigation, because there's so much variation with our hilly terrain out there. That's a bit on that. But this is where we're using these watermark sensors, where you can take these and build a network. So you can actually this feature is rather nice. If you have internet connection, you can use it, or else you have to buy a cell phone contract. But you can put these nodes out and take an image of your field, and you can do this over 4 or 5 miles, provided you have line of sight. And all the little wireless sensors and these little nodes, they all network together, and then you can pull it up on your phone and see what your soil moisture is. But the biggest thing I kind of have a discussion point with farmers is when you look at this type of automation with soil moisture, looking it on here, checking those numbers on your phone, doesn't mean that's your primary decision base. You still have to go out in the field, look at the crop, and see what's going on. You use this as an indicator for your irrigation cycles, but that's not the primary reason, because certain things could be happening out in the field that you wouldn't know unless you went out there and looked. So you just use that as a decision point, but you still have to manually check the field, so you don't become complacent in automation. And that's just the way to do it. But to set up about 20 of those sensors on an individual farm with a subscription, you're looking at about $5 grand a year for that technology, and a subscription cost, if you have to get a cell phone contract, depending where you are, around 100 to 140 bucks a year. So it's a significant investment, but that's something where individual states through NRCS are actually cost sharing for farmers to effectively use water a lot better through these soil moisture meters. So that's a little bit about the irrigation technology we're doing. But what we're doing in my county on our farm is we're taking all this new irrigation technology and putting that into play with our soil health and our measurements, in using cover crops to build our organic matter and make our soils more of a sponge to hold that water that we get out there. So one of the ways that we're assessing that is with our Cornell soil health test, and we do that every year on all our different fields, and through diversified cover crops, we're trying to grow organic matter and reduce our compaction, and through changed tillage practices, that's what we're trying to do to reduce our water usage. So that started on our farm about 7 or 8 years ago, where all of our sweet corn on our farm is still overhead irrigated. So of that 60 million gallons of water that I used in 2016, over 35 million of that was just to grow 260 acres of sweet corn. So a lot more inputs for a smaller amount of outputs. So we started looking at reduced tillage practices, and we were heavily compacted on our soils because we've been farming them for over 100 years. So at about 12 inches we had this great plow pan, so whatever rainfall we got, the water would get there and run off. It wouldn't store within the root zone. So we've aided ourselves by getting rid of that compaction and increasing our storage capacity. So instead of having to overhead irrigate our sweet corn every 4 days, I could actually stretch it to 7 and it wouldn't fall down because we've increased that storage capacity within our soil. But one of the other things on our organic farms and some of our other practices that's been going that Amy showed a little bit earlier is there's been a great movement in our region about reduced tillage, no tillage, and using tarps or things in between rows or plantings to help retain water and reduce weed pressure. So on our farm we have a kind of a unique product where we use this spun-bound woven fabric we get from our row cover supplier, and I'm the only one that has it. They make it for me in 3-foot, 4-foot, and 5-foot widths. It's black and it's UV stabilized, and we call it a real technical term called weed mat. And we're using that between all of our plasticulture rows as compared to the woven ground cover or mum fabric. And the reason we're using this instead of this is the woven stuff acts just like a tarp. So when you're trying to gather all that benefit from the natural rainfall that you get, if you put that woven stuff out in your field, that just sheds the water like a tarp. It shoots right off, so it doesn't go down into the soil, and your soil can't absorb it and give it to your plants. The woven material that we have that's a weed mat, you can see this was just after about a half-inch rainstorm. You can see a little bit of the water left in the trenches as it's permeating through the soil. That allows everything to drain through it. So all the benefits that you're getting from natural rainfall with those in-between weed covers goes to the plant. It doesn't get washed off or create gullies on our hilly terrain where a lot of people using this woven mum fabric just sheds all that water off. Another thing that we're doing a lot too is we're doing a lot of bed sterilization where people are taking silage tarps, using those to kill their cover crops, build that organic matter in the soil, and do that organically instead of using herbicides or roller crimpers to kill the cover crops. And then that's acting as a same principle as this to help store the water in the field versus tarping it and leaving it out there. There is a local resurgence where people are putting the silage tarps out and then they're saying, well, why am I removing them? They put it out there for 6 or 8 weeks and try to sterilize the soil, and they say, well, it'd be so much cleaner if I just leave it out there and plant through it. Well, you lose all that benefit from the rain, and then you actually have to irrigate more because there's no way for the water to get through. So this is a movable thing, but that's a big disconnect that's happening right now in our region. And then we ventured a little bit into no-till crimping, where we transition a lot of our sweet corn from conventionally planted to reduced tillage to no-till. But the reason I like to put this up is we've even double cropped some of our fields with hay, where we take the first cutting of hay off and then we no-till plant into sweet corn, and then we replant some triticale or something to get a forage crop off it afterwards. But just because it's no-till doesn't mean you don't have to irrigate. You can do all the best stuff in the world to build all that organic matter and build the storage of that water, but in a severe drought, your crops still may need to be irrigated. And that's a big disconnect that's happening out in our region. We've got a great movement towards reduced tillage and no tillage, but I still have to supply supplemental irrigation to grow this crop. So in our spring and summertime during the growing season, we're only getting 3 to 4 inches of actual average rainfall. So everybody's like, if you go no-till, you don't have to irrigate. You can build your soils up really far so you don't have to, but at some point your crop is still going to go into stress and you still need to supply irrigation. Another exciting thing that we're playing with too with regards to irrigation is we've got a lot of new no-till transplanter tools out there, where we're taking some no-till transplanters and putting actual plugs out in the ground. And the reason I popped this up is our partners at Chechi Magli, that we're doing with these transplanters. They finally came up with a shank this year, so when we no-till that, it actually puts the drip tape down 3 inches off to the side at the same time. That's something that they haven't had in years past, so we can actually lay drip tape at the same time we're no-till transplanting, where in the past people used to have to no-till transplant, then pull it out by hand, and it was a huge labor expense to do it that way. So now they've got an automation way to do that. But that's where a lot of these new technologies, it's something that everybody's interested in, but it's just developing now. And we're kind of on the precipice of that. But another couple cultural resources is we do get some rainstorms in the summer, but when we do in the Northeast, it's typically these big thunder boomers that dump 1.5 inches or 2 inches of rain in a half an hour and they move on. And then we don't get anything for another 2 weeks. So where we're really looking at our soil health and breaking down that compaction is how do we store that 1.5 inches or 2 inches of rain that comes down really, really fast and get it to infiltrate into the soil and stay there and be available for the plants over 2 or 3 weeks instead of just run off. And part of that is us transitioning from conventional tillage to reduced tillage or no tillage, but also when you do have that 25-year storm, we're really prepping our drainage systems. We've done a lot of swale work and tile work and making sure that that excessive water has a way to get off the field without damaging the crop. And there's a lot of different ways you can do that. But the bigger problem in this design is when we get heavy rainstorms like this for us in the Northeast, it's also taking all our nutrients out. So people will often say, why are you irrigating 3 or 4 days after a heavy rainstorm? And that's to fertigate and put a lot of nutrients back. So that's where that precision irrigation system allows you to do that at a very low irrigation rate to put the nutrients right back to the soil. But you know, that's just some images of what we're getting with some heavy rain, and that was about a 2-inch storm in the strawberry plants from that year. It rained so hard they're actually just washing down into the brook. So kind of bad. But that's a little bit of what we can end up with. And the reason that's a problem for us, where in the beginning of the conversation I was saying a lot of us use surface bodies of water for irrigation. We don't have wells. So we're dealing with algae and sediments in our ponds all the time. So that creates huge problems with us with filtration. If you're using disc filters or sand filters for drip irrigation, they just clog up tremendously. So, you know, that's what we're getting after a 4-hour irrigation run on a typical pond. So it's supposed to start clean like that, and that's just 4 hours of what we're dealing with from what looks like a moderately clean pond. And the reason that's a problem is with that climate change, when we get into the drought, that's that pond I ran out of water, all those heavy storms are washing all that sediment in fertilizers and putting them back into our ponds and creating breeding grounds and adding a lot of stuff into our surface water. So now in those 5- and 10-year droughts that we have to add pond maintenance and sediment cleanup as part of a strategy on our farm, just to catch up everything that's coming out. So we're getting a lot of sediment buildup. That pond used to be 10 feet deep and now it's like 4. So what happens when you do that a lot with your irrigation sources? Well, you can compromise your suctions and foot valves. You can get too much living algae, and it creates huge headaches for irrigation. So what do we have to do now? We're training growers to at least start to float their suctions in the ideal water zone. So 6 inches to 8 inches off the surface, not sucking from the bottom, so you're not in that algae layer. And you're not sitting on the bottom sucking up all that sediment. And sometimes it's as simple as a milk crate zip tied to your suction pipe that keeps the foot valve off the bottom of the pond. I mean, we're not talking technical stuff. Or marine floats. I can't tell you how many different farms I go to and see guys that use, you know, 55-gallon drums or tire inner tubes to hold their suction pipes up, and then they go flat and they're at the bottom of the pond and they wonder what's wrong. So why not spend 60 bucks and buy a marine float, something that's not going to go flat, to hold that up and save you a lot of headaches in the season. So, and something as simple as if you do have a surface body of water or a pond that's got a lot of heavy floating surface algae, just run a garden hose back off your pump and shoot it right across that suction point or that foot valve and use that water flow to help blow it away. This is easier on a pond situation. In a river, you got to get a little bit more volume, but it can be done. And then when you're looking at that you know, this is that same pond where we had to work on some excavation. At least in our region, we're allowed to dig up to 3 feet for normal maintenance if the pond's completely dry without like a environmental services permit or something like that. But when you do that, it's always good to tell those people that you're doing it so they don't come and knock on your door after and say, what the heck are you doing? But when doing that kind of thing, if you know your pump's sitting down here, create a low sump point for your suction where you're always going to draw her out of. So if the rest of the pond fills up, you at least know you have a deep spot where you can withdraw your water surfaces from and kind of aid your irrigation cycle. So that's just a little bit of the local stuff, but you don't want to ever get into this situation where you pumped all your sources dry because you're over irrigating and not using it effectively, that you have to truck it in tankers just to make things survive. It's not always great, but using some cover crops, building your soil health, and the right irrigation tool can really make the optimization of your water usage a lot more effective. So that's what I've got. That's my contact information. Any questions?